So let's do a word problem here. We're given that the height above the ground of a person sitting on a Ferris wheel is described as this formula, so h of t. So the height based upon time is this function here. So we know that in this equation, h of t is the height above the ground in meters, and t is time in minutes. We're going to start at t equals 0 minutes. During the first 5 minutes of the ride, the person will be 10 meters above the ground. So essentially what we're saying, if we go from 0 to 5, we have an interval from 0 to 5. We're going to be focusing on that. So t will be an element of that interval. This 10 meters is your h of t. So if I rewrite that in this formula, h of t, which is 10, is equal to this 18.8 minus 16.7 cosine of 2 pi over 5t. So we're going to solve this problem to find what is our value for t here on that interval for t from 0 to 5, which we'll have to kind of edit that because we want to think about this as in the unit circle. So we'll talk more about that. So solving this, we subtract the 18.8 to the other side, so we get negative 8.8 is in fact equal to negative 16.7, and that's cosine of 2 pi over 5t. So very similar to when we use the law of cosine, it's kind of that same format. Solving that, so when we divide by that 16.7 to both sides, negative 16.7 to both sides, we'll get a positive 8.8 over 16.7 because the negatives will reduce, and this will be equal to that cosine of 2 pi over 5t. Now, this is kind of weird looking, so what we're going to do is replace this right here with let's use u. So we've been using u or z. So let u equal 2 pi over 5 and t. So when I do this, I can rewrite this as this 8.8 over 16.7 cosine is equal to cosine of u, which is kind of nice because now I can solve this and find u. So when you do this, u is equal to the cosine inverse. So cosine inverse of this 8.8 over 16.7, which will give me an answer of 1.015 something, and that is very nice. Now, what do I do with that? Well, that is actually one of the potential answers, or close to the potential answers, that is, because we actually want, not u, we want t in this case. So we're going to figure that out in just a little bit. So, but what we have to do is think about that u will represent an angle on the unit circle. So if I draw a circle, so at radians from 0 to pi back to 2 pi, remember, this is pi over 2. So if you think about it, remember, this is 3.14, about 1 point, this is in radians, remember. There's no degrees, so when we're finding this is in radians. So we kind of have like this angle here. This is about 1.015 radians. Now, if we're thinking about this, we're looking at cosine. Cosine is the x value. So I only want the x value in this. I don't care about this here at all, the y value. I just only care about this x value. But if we notice, this x value will also be the same x value down here with this angle. So the idea is I can also find this angle all the way around here, and it would still be the correct answer. Now, how do I find that? Well, there are a couple ways you can do it, but the biggest way is just looking at the unit circle and saying, well, if this is all 2 pi, and we know that if we think about it, this is kind of going this way as negative 1.015, we can just take 2 pi, which is the full circle, and minus this 1.015, which will give us that this red angle right here, this red angle right here is in fact about equal to, again, I'm rounding this, about 5.267, So that is useful. And why did we go on the unit circle, by the way? If we plug in this 0 to 5 into right here, if I plug in 5 for this, we get 2 pi. So if I put time as t is 5, we get 2 pi. If I put 0, I get 0. 0 to 2 pi, because I'm going on the integral from 0 to 2 pi or 0 to 5, they will correspond because I can substitute that in. That's why I went through here from 0 to 2 pi. Now, all we have to do is solve for t now. So you take this right here, and put 2 pi over 5, t is equal to this 1.015, dot, 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 and we put in this 2 pi over 5, t is equal to this 5.26, dot, 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 dot. Again, you'd want to use all of the decimals or maybe 4 or 5 of them, and then you would use the actual pi symbol and then divide all this side by this 2 pi over 5 to get our t values. So once you do that, you can divide both sides to get that this is 0.81, rounded to the nearest hundredths. I think it asks us to find that. I'm not exactly sure. I don't remember what we wrote down. And this will be minutes. And then this one, or we'll have t is about, if I divide all this side by 2 pi over 5, we should get about 4.19 minutes. So this is a very difficult problem, but it's kind of fun and a good introduction into later and kind of moving and switching around variables. So how about you try this one? I will have an answer shortly. It is a very difficult type of problem, but try it. I'll have an answer shortly. So hopefully you tried it. The only difference is because we're using sine is the y value. So instead of going the x value the same, we're doing the y value the same. So you'd have this angle here, and then the same one with the same y value is this angle here. But we're using pi minus the opposite of this angle. So pi minus this is 0.608 to be coterminal, or not coterminal, but the same y value. So this will match this. So we get those two numbers. We're going to set equal to the 2 pi over 365t. Now, again, we are using 365 because there's 365 days in the year. And if I plug that in, this would end up being 2 pi. And if I plug in 0, I get from 0 to 2 pi. That's why we use the whole unit circle. But in this case, we're only finding this blue and green angle.